ముందుగా అందరికీ వినాయక చవితి శుభాకాంక్షలు. వెల్కమ్ బ్యాక్ టు మై BSS స్టడీస్ అండ్ ద టుడే టాపిక్ ఈస్ kinds of forces. Kinds of forces. So we already discussed about normal, which means perpendicular force, weight means, so if I take like this a surface and this is an object with mass m and the weight acts downwards only always. W is equals to mass into gravity. Okay, so towards upward normal is present. Okay, so this is the FBD of normal body, FBD of rest body. Okay, so these are the topics we already learned, and another is magnetic force. Magnetic force, and these are all contact forces. Okay, so these are all contact forces, and there is no need of learning the non-contact forces because there is no force of non-contact, which means we have to say an object with any point at contact, so we can say any force, but in non-contact we cannot see the forces. Okay, so these are the kinds of forces, and our next topic is FBD. FBD, and the FBD means free body diagram. Free body diagrams. Okay, so if we see what is free body diagram means, first the definition of free body diagram: isolate the body if there is a external force is applied and make it into in a rest position. So if you see the definition, free body diagrams means free body, FBD means free body diagrams, and isolate the body. First we have to isolate the body. For example, what is isolate the body means, for example, if I take like this a horizontal road and the car is traveling like this, and it reaches some displacement after t seconds. Okay, so if we apply brakes, the car stops. Okay, the car stops and there is no acceleration is 0, and final velocity is also 0. Okay, the final velocity also 0. So we can say this is in rest position, and we can say the weight of this object means downwards. W is equals to mg. Okay, mass into gravity, and the upwards means normal. Okay, so this is the isolation of the body. Okay, so like this we have to isolate. And if we see some cases, first note down this definition and we can see the cases. And if you see some cases of FBD, first one, rest position, which means, so if I take 2 kg body like this, 2 kg body, and the gravity and weight acts downwards, the weight is 2 into 10 kg meter per second square, which is nothing but 20 newtons. Okay, so weight downwards acts, and the upwards is 20 newtons only, because this is in rest position. Rest position means there is no external force. So here 20 means here also 20. How it is in rest means like this 20. Here opposite forces are there. The downwards weight and upwards 20 newtons. Upwards 20 newtons means opposite are there. 20 minus 20, 0. There is no external force. Okay. So like this we can see. Here upward is normal. Here normal is equals to 20 newtons and weight is also equals to 20 newtons. So otherwise we can say W minus N equals to 0. So this is the main FBD equation for this FBD body. Okay. So here 20 newtons. And if you see second one, 2 kg, 1 kg, 2 kg, 1 kg. So if you see here, if we give one body like this, we have to isolate the body, and if they give two bodies, how to do? So I am taking the first this one, and here normal 1, normal 2. Two normals are there. 2 kg, normal 1, 1 kg, normal 2. Here this is the normal. N is equals to 20. So if you see how to isolate these two bodies means, first take this down body. So if you see the down body 2 kg like this, it is there. Here the weight is nothing but 20 newtons. Here 20 newtons how we will get means, we have to remember the value of gravity as 10 meter per second square or 9.8 meter per second square. So this is the very simple unit than this. Simple expression than this. So we have to use this only. Okay. So unless they mention the gravity as 9.8 meter per second square. Okay. So this is 20 newtons, and we can say first we have to isolate the body, and isolate the body means we have to keep it in rest. Okay. So here 20 newtons means W minus M is equals to 0. Weight minus normal is equals to 0. So here we already get weight. So 20 minus N is equals to 0. N is minus N is equals to minus 20. Minus minus gets cancelled. N is equals to 20 newtons. Okay. So upwards 20 newtons. Here upwards 20 newtons means this is N1. Okay. Sorry, not N1. This is N2. Okay. So this is the free body diagram of 2 kg, and if you see 1 kg, downwards 10 newtons, upwards 10 newtons. See, downwards 10 newtons, upward 10 newtons. So like this we have to isolate. If they give separately, here they give connectedly. Here we have to we are doing that these two are separate bodies, but they give connected bodies. So if we see connected bodies, here the normal N1, N2. So here take 2 kg like this, and the gravity acts downwards, which means 20 newtons. And here N2 is there. N2 is there means here 1 kg is equals to downwards N2, and here upwards is N2. Okay, and here downwards N1. Okay, so if you see here like this, we have to do. Here I am taking only 2 kg body, not surface. Here downwards N1 and downwards 20 newtons, which is weight, and this is the surface, this is the N1. So what is N1 means? N1 is 20 newtons only. So right, N1 is equals to 20 newtons. And how to find N2 means? Here this is the normal N2, and here this is N2. Here 1 kg downwards means this is, we can say 10 newtons, because as per the weight, W is equals to mg. So here this N2 10 newtons means this N2 also 10 newtons. So N2 is equals to 10 newtons. Okay. So if they ask the sum of these two normals, N1 plus N2 is equals to 10 plus 20, which is nothing but 30 newtons. Okay. So like this we have to draw the free body diagram, and we have to represent the forces on it. Okay. So simply they can ask like this also. What is the sum of the normals when they are connected? Okay, when they are connected. If you see the sum of, they ask the sum of normals, which means here the total force acts downwards only, which means 1 kg plus 2 kg, 3 kg body. Here we can take this whole body as 3 kg body, and the 3 kg body applies some force on ground. On ground means 3 into 10 newtons, which means 30 newtons. So this is the final force. Okay. So if they ask sum of normals, so this is the second case. And if you see third case, this is 2 kg body, and it is going towards like this. Force F. You have to find this force. If this body is going with acceleration 2 meter per second square, and the external force acts like this. This is 20 newtons, and the downwards 20 newtons. Okay, so this is the one of the case. And if we see the free body diagram, here see free body diagram means first isolate the body 2 kg, downwards 20 newtons, and downwards 20 newtons, and this is the surface. And here they give acceleration 2 meter per second square, and here we have to find the force. Force is nothing but mass into acceleration. Okay, see here downwards 20 and here also downwards 20 means both are in same direction. Same direction means we can say 40 newtons. Here very important point, same direction means we have to add the forces. Opposite direction means we have to subtract the forces. Okay, so if you see acceleration is 2 meter per second square, and here downward is 40 newtons, and here they are asking to find the force. Here how to find the force means, here very important point, here the gravity, which is nothing but 40 newtons, there is no effect of this force for pulling this force. Okay, so there is no effect for pulling this body towards like this. Okay, so we can eliminate this force. Okay, so we can eliminate this force, and they are asking to find that acceleration they gave, mass they gave, which means 2 kg into 2 meter per second square. We have to find the force along this direction. There is no effect on 14 newtons, so we can neglect that 14 newtons or eliminate that. If you see 2 kg into 2 meter per second square, which is nothing but 4 newtons. So the final force is 4 newtons. Okay, so this is one of the case. And the fourth case. Here they give one of the body, and this is the lift. Lift going towards upwards with the acceleration of 5 meter per second square. Okay. So if we draw the free body diagram of 2 kg, and very important point, here we have to find the force. Okay, or normal. Here if you see, the gravity acts downwards is 20 newtons and the upwards is 20 newtons because it is in rest. Okay, and it is going towards upwards. A is equals to 5 meter per second square. Okay, so if you see, there is no need of this free body diagram when they give like this case. Okay, simply we can use the formula n is equals to m into g plus a. So this is the formula, because here this is going towards upward, means the full force acts towards that direction only. Okay, so n is equals to 2 kg into gravity 10 plus acceleration 5, which means 2 kg into 15 meter per second square, which means 30 newtons. And the total force acting towards the direction is 30 newtons, which is equals to normal. Okay. So this is the fourth case. And if you see fifth case, two kg, and it is coming towards downwards with the acceleration of 5 meter per second square. Okay, so there is no need of free body diagram again. So the formula for coming towards downwards with the acceleration, positive acceleration, means n is equals to mass into gravity minus acceleration. Okay, so here normal is equals to mass 2 kg into gravity 10 minus acceleration 5 meter per second square, which means 2 kg into 5 meter per second square, which is nothing but 10 newtons. Okay, so this is the final force acting towards down when they are coming towards downwards. Okay, so this is the fifth case. And the today topic is completed. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. If you have any doubts, please comment on the comment box. Thank you.